When we show what we've developed so far to our users at the travel agency, they approve it and remind us that for each tourist attraction, they want to record the city in which it's located. Therefore, our application must take into account that countries contain a set of cities, and also that each tourist attraction belongs to a city. Genexus provides an easy way to represent a reality such as this of countries and cities. It's implemented by adding a second level to the country transaction. Let's see it in action.
We open the country transaction and, while positioned on the last attribute, we right-click and select Insert Level. As we can see, a sublevel is opened. We call it City. Now there are two possible ways to name the attributes on the second level. If we type a period, we see that Genexus suggests country city as prefix. That is to say, the transaction name plus the second level name. We would only have to complete the attribute name in this way. If, on the other hand, we type inverted commas, we see that Genexus suggests the prefix city, the second level name. We would only have to complete it by adding ID at the end, and we would have the name city ID. We'll leave it like this. Note that it takes the ID domain. And in the next line, we also type inverted commas and complete the attribute name with name. We save the changes, and note how Genexus has changed the web form for this transaction after creating a second level with cities. As we can see, for each country, now we can enter a group of cities. Note that the second level of the transaction, named city, is displayed in the form as a grid control. And inside this one, the attributes define there. In this way, for each country, it's possible to enter a group of cities. Let's go back to the transaction structure. This two-level transaction represents that each country contains several cities, and that each city belongs to a single country.
For every two-level transaction, Genexus determines that it has to create two physical tables. One table arises from the first level, in this case to record the countries, with country ID primary key. And another physical table associated with the second level, which in this case is used to record the cities in each country. Let's focus on the primary key of the second table that'll be created. It's composed of two attributes, country ID and city ID. This means that the unique identifier of the cities is composed of both attributes. Let's execute the application to see this. We press F5. Note that Genexus is proposing the creation of a table called country city in the database. This is the table created from the second level that we defined in the country transaction, and its name is taken from the transaction name plus the name we gave to the second level. As we explained before, its primary key is composed of the country ID and city ID attributes. We execute the creation of this table in the database. The necessary programs are generated, and the application is run. We'll execute the country transaction to add some cities for the countries that we've entered. We query the first country that we've entered, it's Brazil, and we add a city to it. We identify it as City 1 of this country, and it's called Rio de Janeiro. Now we'll enter another city for Brazil, and code it as City 2 of Brazil. It's Sao Paulo. We confirm. Now we go to the second country that we've entered, which is France. We add only one city, Paris. And we'll confirm. Lastly, we'll add cities for China. We find China, and we add as city number 1, Beijing, as city number 2, Shanghai, and as city number 3, Hong Kong. We confirm. As we can see, different countries can have their cities identified as number 1, 2, or 3 respectively, because cities are not only identified by their city number, but they're also identified according to the country to which they belong. Note that for the same country, the city identifier value cannot be repeated. The application informs us that this country already has a city with this identifier value.
Now let's go back to Genexus and assign a city to each attraction. We open the attraction transaction and add a new attribute. We type C and choose City ID. We press Enter to add another attribute and choose City Name. At the travel agency, we were told that the attraction city must give the option to not set it. To meet this request, in City ID, we will set the nullable property to Yes. As we've said before, this property is only set to Yes for foreign keys, because in this case, the reference value is checked for existence. This is the way to also enable the value to not be set. The order in which the attributes are entered in the transaction is the same as the order in which they will be displayed in the web form. If, for example, we move the city ID and city name attributes, leaving them under the country name attribute, and save the changes, we can see that the order is also changed in the web form.
And press F5. We're informed that the attraction table needs to be converted by adding the city ID attribute, which can be left unset. We'll proceed to reorganize it. We save the changes and upload the modified objects to GX Server. We then select Knowledge Management, Team Development, add a comment, and press Commit.
To sum up what we've seen, when a transaction has more than one level, each level will have a table associated with it. The primary key of the subordinate level tables ends up being the combination of the identifying attributes of the level itself and those of the parent levels. In this case, City ID plus the city level identifier, which is Country ID. This Country ID identifier in City silently converts it into a foreign key of the country table, and this is what creates the relationship between the two tables. However, because it's not only a foreign key, but also part of the primary key in the city table, cities are a weak entity in relation to countries, since in order to identify a city, we need to identify the country to which it belongs.